Hi, I'm gonna redo the hypergeometric one. My video won't upload, so actually I'm going to start this section over again, and you'll have it in two spots in your notes. But hi, I already tried to make a hypergeometric worksheet video, but it wouldn't upload. So I'm just going to start the whole thing again and see how that goes. So we have two problems at the bottom of your Chapter 5 worksheet, and I want to make sure you have the solutions to those. So I'm going to work those out here. So looking at the first one for CEOs, we have a population of 10 CEOs, so that's the population size, and we use capital N. And then it says in this group only 3 are under 60, so we're going to make under 60 is a success. And since there are 3, R is the number of successes in the population. And so we see here that there's 3 of them in the population. Then you look at the sample, and it says we're going to sample out 5 of the CEOs, so the sample size is 5, and that's a small n. And it also tells us that after we sample them, 3 of them are under age 60, so we're going to use X for the number of successes in the sample. So the hypergeometric has success and failure, but we have to keep in mind both the sample size, population size, successes in the population, and successes in the sample. So now I want to find the chance of X. We're going to have multiplying 2 different combinations on the top, and then divide by the bottom, which is the full population size, and we pick out small n. On the top, we have how many successes in the population and how many successes that we get in our sample. Then we have how many failures in the population and how many failures in the sample. So looking at what we've got, we have 3 successes in the population, and we're going to find the chance of getting all 3. Then we're multiplying that by the fact that there's a population size 10, but 3 of them are not a success, sample size of 5, and 3 of them are 3 minus 2, so we'll have 2 failures in the sample. And in the whole population, we're counting all the ways we could pick 5 out of the 10 possible people for our sample size. So keep in mind that any combination works like this. We have R factorial would be on the top, X factorial would be on the bottom, and then R minus X factorial. That's what we're doing for each of our combinations. So when we look at the ones we have, we need 3 factorial on the top, 3 factorial on the bottom, and 3 minus 3 factorial is just the first one. Then we're going to have 7 factorial on the top. 2 factorial on the bottom, and 5 factorial on the bottom. And then the whole thing is going to be over 10 factorial divided by 5 factorial and 5 factorial. So working these out, we are going to have this for the first one. Remember, 0 factorial is equal to 1, so it doesn't divide by 0. So the first one is going to turn into a 1. The second one is going to be 7 times 6 times 5. I'm going to write these out, but you could work them out in your calculator. And so what our numerator should turn into is we're going to have a 1 times a 21 let's see, 5 times 4, this becomes a 3. So we have 21 on the top, and then the bottom becomes, I'll write these out. All of those cancel. And we're going to get, again, you don't have to get all those to cancel the way I did, but you should end up with, on the bottom, you'll get 252. So let me just double check. All those 5 factorials cancel. I canceled this 6 with a 3 and a 2. I canceled that 8 with a 4. It should have been a little tiny 2 right there. And I canceled the 10 with the 5 and I got a 2. So I should have a 2, a 2, a 4, and a 7. Let's just double check that. That's a 60. Sorry, it's a 9 times a 4 times a 7, which equals 252. Okay, it works out 252. I cross-canceled differently this time. So the final answer of 21 out of 252 will become an 8.3% chance. So back to the original problem, there's an 8.3% chance that if 3 of the CEOs are under 60, and then we pick 5 of them, we're going to get all 3 of those. Okay, let's work out the next one is number 2. In this story, there's 8 runners. And so that's my whole population. Out of that group of runners, 3 had a better race in the Olympics. So that's the successes in the population. Then we're going to take a sample of 2 runners and find the chance that one of them had a better race. So doing the same set of 2 combinations in the top, but the bottom is a total of 8 options and we choose 2. The top has a combination of 3 successes and we pick 1 multiplied by a combination of 8 minus 3 or 5 failures, and we choose, since we're only choosing 2 runners, we get 1 of those. And when we work this out, we're going to have these 2 combinations on the top. And these 2 combinations on the bottom. So the first one works out to be just a 3. The second one works out to be just a 5. The bottom one works out to be 28. So we have a total of 15 out of 28, which is a final answer of 53.6% chance from the sample of 2 runners. One of them had a better race. So let's stop there on the hypergeometric.